Probability Part 1. An experimenter testing for extrasensory perception has 3 cards with pictures of a star, a circle, and wiggly lines. She selects 2 cards without replacement. Outcomes in the sample space are represented by pairs such as WS and SC. Complete parts A through D below. Part A asks us how many elements are in this sample space. Well, we're told that we have 3 cards. One card represents a star, then another represents a circle, and the other is wiggly lines. We're going to write the sample space of selecting 2 cards. And remember, we're going to use S to represent the star, C to represent the circle, and W to represent the wiggly lines. I can represent all the outcomes of selecting 2 cards without replacement systematically. First, I'm going to assume that I drew a star. Now, I can't draw another star because I'm not replacing the star card back in the pile after I draw from it because the problem tells me I'm selecting it without replacement. So if my first card that I draw is a star, the second card can either be a circle or the second card can be a wiggly line. Those are my outcomes for selecting a star first. Now I can move on to a circle. So let's assume I draw a circle first. Then I can draw a star, and I can also draw a wiggly line. Again, I can't draw another circle because I'm not replacing the circle card back in the pile. Now I'll move on to the wiggly line. So I have a W, and I can either draw a star or I could draw a circle. So I have those 2 pairs. And this set is my sample space. These are all the possible outcomes of drawing 2 cards without replacement. So part A wants to know how many elements are in the sample space. Well, here's my sample space, so I'll just count the number of pairs that I see. And there are 6 pairs, so my answer to part A is 6. Part B says express the event a star appears on one of the cards as a set. Choose the correct answer below. So I'm going to go back up to my sample space and just highlight the pairs that have a star appearing on one of the cards. So I have this pair because there's an S in it. I also have this pair, then this pair, and this pair. So altogether I have 4 pairs, and that corresponds to choice B, which is pair SC, pair SW, pair CS, and pair WS. Part C. What is the probability that a star appears on one of the cards? I just wrote my entire sample space again, and those are the 6 pairs that we listed in Part A of the problem. Now, I want to know the probability that a star appears on one of the cards. Probability is represented by NE over NS. That means it's the number of times an event occurs over all total possible outcomes. So NS is the number of outcomes in my sample space, and we said that this was 6. That was our answer to Part A. NE is the event that a star appears on one of the cards. And this was our answer to Part B. We said that a star appeared 1, 2, 3, 4 times. So NE is 4. My probability is 4/6, but I want to write fractional probabilities in reduced form. Since 4 and 6 are both divisible by 2, I'm going to divide the top and bottom by 2. So 4 divided by 2 is 2, and 6 divided by 2 is 3. So my probability that a star appears on one of the cards is 2/3. Part D. What is the probability that a circle does not appear? I'll go back up to my sample space, and I'm going to circle the pairs where C, or a circle, is not part of the pair. So I have SW, and then I have WS. So a circle does not appear on a card 2 times. So when I write this in probability form of NE over NS, I have 2, because NE is the number of times that a circle does not appear, over 6, because NS is the total number of all possible outcomes in the set. Now my probability is 2/6, but I want to write this as a reduced fraction. 2 and 6 are both divisible by 2, so I can divide the top and bottom by 2. 2 divided by 2 is 1, and 6 divided by 2 is 3. So my probability for part D is 1/3, and that's the probability that a circle does not appear.